Everybody, in this video we are going to talk about amortization. Okay, and I googled it to find what I thought was a good definition, and here is one I like. Right, so basically this is the part I want to highlight. Most commonly when amortization is used is if you borrow money and your lender, such as a financial institution, is coming up with a loan repayment schedule for that loan, right? So that's really what the context of amortization is going to be for us. Okay, so I'm going to again use the finance solver, right? We'll use the finance solver, but I'm going to use Revision Village because, yeah, I just like it for these questions. Okay, so here's a question we're going to look at. Olivia takes a mortgage of $250,000 out to buy an apartment in Sydney. Okay, so that's the loan amount. The loan is going to, the interest rate on the loan is going to be 3.49% per year. Compounded semi-annually, so this means twice, right? 2 times per year. Olivia agrees with the bank to amortize the loan in monthly payments, so she's going to pay monthly, made at the beginning of each month. Okay, so with these loans, the beginning or end, just like with annuities, kind of it matters. Okay, so part A, question 1, what's the monthly amount if the loan is to be amortized over 30 years? Okay, so we'll go to the Nspire, and let me just tab all the way to the top. All right, so in this case, N, right, number of payments. So she is paying monthly for 30 years, so she's going to make 360 payments. The interest rate annually is 3.49%, I believe. The present value, so that's the loan amount, right? Because that's what she got. So she received $250,000. That's her present value. The payments is what we want to, I believe, calculate. Yeah. Okay, so that's blank. The future value, we want to zero it out. We want to make the loan 0. Payments per year is 12. Number of times the interest is paid or compounded per year is 2. Okay, so I think that should do it. And if we go back to payment and push enter, we get 111771. Let's check that. I think that's right. 111771. Why is this off a little bit? 360, 349's right. That's right. Future value 0. 12 and 2. 360, 349. I don't really know, guys. Why is this off? 360, 349, 250. Future value 0. Did I? Yeah, I'm actually not sure why this is doing this incorrectly. Oh, let's put that back to 2. Okay, 111. Oh, I know what it is. Sorry, guys. I know what it is. It's the timing. Yep. Payment. Hey, good lesson learned, right? She's paying at the beginning of the month. Okay, and what this will do, and we'll see, this is a good example of it. This is going to lower the payment, right? So because she's paying at the beginning of the month, right, every time that loan has a little bit less time to grow, right? Because you're basically paying some of it back earlier, right? So you can see it's interesting how just the time of the month, that you make your payment actually affects the payment amount. Okay? So, geez, glad I caught that. The total amount paid, well, I don't want to go, all we need to do, guys, is take this number, this payment amount, and multiply by 360, okay? So that's pretty easy, hopefully. And did they just show that here? Yeah, right, so there's the payment times 360. So she pays $401,000 over, a 30-year period to loan, or to borrow $250,000, okay? Part B. Let me go back to this. Olivia has the capacity to increase her monthly payments by 85. Justify why this might be a smart financial choice. So essentially what's going to happen is if she pays more monthly, she's going to knock off some of that loaned amount, and there's going to be less money accruing interest, right? So yeah, let's change this. Okay, so if we just adjust this and we basically add 85 to it, so that's going to make this amount, if I add 5 to it, that's going to be 99. Okay, we still want it to zero out. Everything else is still the same, but what will happen is if I push enter now, so that means she only has 317 payments to make, so she saves, right, a pretty big amount of money. So if we take 11995 and multiply by 317, I hope they've done this in the solution. Let's see. Yeah, here it is. I don't know if you guys can see this, but 11995 times 317 is 19958, and sorry, this is the two total amounts, right? So we took the original amount, multiplied by 360, the amount monthly increased by 85 and multiplied by less months. So she paid $19,000, almost $20,000 less, and she got the loan paid down in 3.5 years sooner. Okay, so kind of pretty cool for us to be able to see how just increasing the payment a little bit will reduce the number of payments you have to make, and also therefore decrease the total amount that you paid. So yeah, I hope that was helpful, and see you on the next video.